Hi, welcome to Nomi's Academy. In this video, we are going to learn how to find the differentiation or how to solve differentiation from first principle. Alright, in the previous video, I explained how to find the derivative of a function. So today we are going to use that idea to learn how to solve problems involving differentiation from first principle. Let's pick the first example, example 1. Find the derivative of f of x equal to x squared from the first principle. Alright, whenever you are asked to find the derivative of a function, considering a limiting value is actually called differentiation from the first principle. That is, trying to find the derivative of a function considering a limiting value is what we term as differentiation from first principle. Alright, let's solve that. Solution. We have f of x equal to x squared. Now, increment in x would definitely lead to an increment in f of x. So that will be in this form, f of x plus delta x. Delta x is the increment, and that will give us s plus delta x squared. So increment in x would definitely lead to increment in f of x. Alright, let's go further, and then this will give us, when we expand this, we'll definitely get x squared plus 2x delta x plus delta x squared. Alright, so that is the expansion to this. I believe you know how to expand and problems of this order. Alright, the next thing we need to do, we need to go further to subtract f of x from this function, from the increment. So we have f of x plus delta x minus f of x. So that will be x squared plus 2x delta x plus delta x squared. Then we subtract f of x from it. As you can see, we subtracted f of x from this side, from the left hand side. So we're also going to subtract f of x or x squared from this side. So that will give us, x squared minus x squared is 0. So it's cancelled already. And then we have 2x delta x plus delta x squared. So that's what we have. Then the next thing we need to do, we need to divide by delta x. So fx plus delta x using the function pattern. F of x plus delta x minus f of x all over delta x. And that will give us 2x delta x plus delta x squared all over delta x. Now, when you divide, of course, you know this, we cancel this, we are left with 2x. And then plus this, we cancel this, we are left with delta x. Delta x. So let's go further. At this point, we are going to take the limit of the function. Remember, I said whenever you are asked to find the derivative of a function using or from the first principle, what you are going to do, you always need to consider a limiting value. A limiting value. In that process, you are actually solving the differentiation from the first principle. So considering the limiting value, we have the limiting value of this function, and that will be limit as delta x tends to 0. We have f of x plus delta x minus f of x all over delta x. And then we also have the limiting value as delta x tends to 0. In this case, we have 2x plus delta x. So you remember in my previous video, I said the limit as delta x tends to 0 of this particular function would definitely lead to what? The slope or the gradient of the curve, which is dy dx. But since this is the function pattern, we write f prime of x. F prime of x is also known as dy dx. They are the same thing, but since we are using the function pattern, we are going to write f prime of x. So the limiting function here is f prime of x equal to, in this case, delta x tends to 0, so we have this to be 0. As delta x tends to 0, so what we have left is 2x. So 2x is the solution to the problem. That's the derivative of the function from the first principle. Thank you for watching. See you in the next video. Thank you.